23 underscore Ms underscore 42. 4. This question is about lead 2 chloride, PbCl2. A student prepares a sample of insoluble lead 2 chloride, PbCl2, by mixing aqueous solutions of 2 salts in a beaker. Identify 2 soluble salts suitable for making lead 2 chloride when mixed together. M1 lead nitrate 1. M2 soluble chloride e.g. sodium chloride 1. 4a. Write the ionic equation for the formation of lead 2 chloride by mixing aqueous solutions. Include state symbols. 4a. List the steps the student should take in preparing a pure sample of lead 2 chloride from the mixture in the beaker. M1 filter 1. M2 wash the residue using water 1. M3 dry the residue between filter papers in a warm place 1. 4b. The student carries out an electrolysis experiment on molten lead 2 chloride using the apparatus shown in Fig. 4.1. Chlorine gas forms at the anode and escapes from the apparatus. Explain why lead 2 chloride needs to be molten before it will conduct electricity. Mobile ions. 4b. Write the ionic half equation for the reaction occurring at the anode. M1 any negative Cl species losing electrons 1. M2 correct ionic half equation 1. 4b. State the test for chlorine gas. Test. M1 damp litmus paper 1. Observations. M2 is bleached goes white 1. IV describe what is observed at the cathode. Shiny gray and solid. 0620 underscore W23 underscore Ms underscore 43. 4. AI name the limiting reactant. Dilute sulfuric acid. 4a. State 2 observations that indicate the zinc is in excess. M1 solid remains solid undissolved 1. M2 bubbling effervescence fizzing stops 1. 4a. Name the filtrate. Aqueous zinc sulfate. 4a. Name 2 compounds which both react with dilute sulfuric acid to produce aqueous zinc sulfate. Ne2. Zinc oxide, zinc carbonate, zinc hydroxide. 4b. Zinc sulfate crystals are produced by heating aqueous zinc sulfate until a saturated solution is formed. When the saturated solution cools down, crystals of zinc sulfate start to form. State what is meant by the term saturated solution. M1 a solution containing the maximum amount of solute dissolved, no more solute can dissolve 1. M2 at a given temperature 1. 4b. Explain why crystals form when the saturated solution cools down. Solubility decreases as temperature decreases. 4c. State the term used to describe crystals that contain water of crystallization. Hydrated. 4c. State why step 4 is repeated until there is no change in mass. To ensure all the water of crystallization is removed. 0620 underscore S23 underscore Ms underscore 42. 1a D1. 1b C1. 1c H1. 1d B1. 1e C1. 1f G. 4. Solid sodium hydroxide is a base which dissolves to form an aqueous solution, NaOH-AQ. 4a. State what is meant by the term base. Proton acceptor. 4b. State the term given to a base which dissolves to form an aqueous solution. Alkali 1. 4c. State the color of thymolphthalane in NaOH-AQ. Blue. 4d. Complete the word equation for the reaction of NaOH-AQ with ammonium chloride. M1 sodium chloride, M2 water, M3 ammonia. 4e. Some metal oxides react with NaOH-AQ. State the term given to metal oxides which react with bases such as NaOH-AQ. Amphoteric oxides. 4e. Name a metal oxide which reacts with NaOH-AQ. Aluminium oxide, or zinc oxide. 4f. Ethanoic acid, CH3COOH, is a weak acid. Complete the dot and cross diagram in Fig. 4.1 of a molecule of ethanoic acid. M1 all single bonding dot and cross pairs correct. M2 double C equals O bond dot and cross pairs are correct. M3 complete diagram is correct. 4Fe suggests the pH of dilute ethanoic acid. 3 is less than or equal to pH less than 7. 4Fe complete the symbol equation to show the dissociation of ethanoic acid. 4FiV write the ionic equation for the reaction when an acid neutralizes a soluble base. 4G 0620 underscore W22 underscore Ms underscore 43. 5. This question is about sulfuric acid, H2SO4, and salts that can be made from sulfuric acid. 8. Sulfuric acid is manufactured by the contact process. Stage 1 molten sulfur burns in air to produce sulfur dioxide. Stage 2 sulfur dioxide reacts with oxygen to form sulfur trioxide, SO3. Stage 3 sulfur trioxide reacts with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4 oleum is converted into sulfuric acid. The equation for the reaction in stage 2 is shown. State the temperature and pressure used in stage 2. Name the catalyst used in stage 2. Temperature, M1451. Pressure, M2121. Catalyst, M3 vanadium V oxide 1. 5AE. Write the chemical equation for the reaction in stage 3. 5AE. Name the substance that reacts with oleum in stage 4. Water. 5B. Name the black solid that is produced when concentrated sulfuric acid is added to sugar, C12H22O11. Carbon. 5C. Dilute sulfuric acid and aqueous potassium hydroxide are used to make aqueous potassium sulfate. Calculate the volume of 0.0625 moles per cubic decimeter dilute sulfuric acid, H2SO4, that completely reacts with 25.0 cc of 0.100 moles per cubic decimeter potassium hydroxide, CO, to produce aqueous potassium sulfate. Use the following steps. 5CE. The experiment is repeated using the same volume and concentration of potassium hydroxide and the same concentration of dilute sulfuric acid. In this second experiment, the product is aqueous potassium hydrogen sulfate, KHSO4. Use your answer to CI and the equation to deduce the volume of H2SO4 required. 40. 5D. Aqueous potassium hydrogen sulfate, KHSO4 contains the ions K plus AQ, H plus AQ, and SO42 AQ. A flame test is carried out on aqueous potassium hydrogen sulfate. Lilac flame. 5De. Solid copper 2 carbonate is added to aqueous potassium hydrogen sulfate. Ne2 from solid disappears. Blue solution. Bubbles, effervescence, fizzing. 5De. An acidic solution containing aqueous barium ions, Ba2 plus AQ, is added to aqueous potassium hydrogen sulfate. White precipitate. 5E. Write the ionic equation for the reaction in DE. Include state symbols. O620_S22_Ms_42. 2. Calcium hydroxide, CaO2, is slightly soluble in water. A calcium hydroxide can be made by the reaction of calcium with water. Write the chemical equation for this reaction. 2A. Name another substance that reacts with water to form calcium hydroxide. Calcium oxide 1. 2B. When calcium hydroxide dissolves in water, it dissociates into ions and forms a weakly alkaline solution. Suggest the pH of aqueous calcium hydroxide. 7 less than pH less than slanted equal 12:1. 2BE. Give the formula of the ion responsible for making the solution alkaline. OH1. 2C. Limewater is a saturated solution of calcium hydroxide, CaO2AQ. Name the gas limewater is used to test for. Carbon dioxide 1. 2Ce. Suggest what is meant by the term saturated solution. A solution that can dissolve no more solute. At a given temperature. 2Ce. Describe how you would make a sample of limewater starting with solid calcium hydroxide. Add excess solid calcium hydroxide to water. Filter. 2CIV. Describe how you would test for the presence of calcium ions in a sample of limewater. Test. Aqueous sodium hydroxide 1. Observation. White PPT. Insoluble remains in excess. 2D. A 25.0 cc sample of limewater is placed in a conical flask. The concentration of CaO2 in the limewater is determined by titration with dilute hydrochloric acid, HCl. Name the item of apparatus used to measure the volume of acid in this titration. Burette. 2De. State the type of reaction which takes place. Neutralization. 2De. As well as limewater and dilute hydrochloric acid, state what other type of substance must be added to the conical flask. Indicator. O620W21_Ms_42. 2. Acids are important laboratory chemicals. Some acids completely dissociate in water to form ions. State the term applied to acids that completely dissociate in water. Strong. Complete the equation to show the complete dissociation of sulfuric acid in water. 2A. State the color of methyl orange in sulfuric acid. Pink, red. B. The equation for the reaction between powdered zinc carbonate and dilute nitric acid is shown. Complete the equation by adding state symbols. 2be, a student found that 2.5 grams of zinc carbonate required 20 cc of dilute nitric acid to react completely. M1125. M22. 5 125 equals 0.0200. M30.0200 times 2 equals 0.0400. M40.0400 times 1020 equals 2.00. 0620_W21_Ms_43. 5. Dilute sulfuric acid and aqueous sodium hydroxide can be used to prepare sodium sulfate crystals using a method that involves titration. I2 Many color changes. 5. Name an indicator that can be used in this titration. Any acid-base indicator, e.g. methyl orange or phenolphthalein. 20.0 cc of dilute sulfuric acid neutralizes 25.0 cc of 1.00 moles per cubic decimeter aqueous sodium hydroxide. At the end of the titration, the conical flask contains aqueous sodium sulfate with the dissolved indicator as an impurity. 5b. Describe how to prepare a pure sample of sodium sulfate crystals from the original solutions of dilute sulfuric acid and aqueous sodium hydroxide of the same concentrations. You are not required to give details of how to carry out the titration. M1 Repeat without indicator using same volumes or remove indicator by adding charcoal or carbon and filtering 1. M2 Evaporate, heat, warm. Boil, leave in hot place 1. M3 Until most of the water is gone, some water left. Saturation point, crystallization point, evaporate some of the water 1. M4 Cool, leave to crystallize 1. M5 Description of drying 1. 5c. Sodium hydrogen sulfate, NaHSO4, dissolves in water to produce an aqueous solution, X, containing Na+, H+ and SO4 2 ions. State the observations when the following tests are done. A flame test is carried out on X. Yellow flame 1. 5ce. Copper 2 oxide is warmed with an excess of X. M1 solid dissolves disappears 1. M2 blue solution 1. 5ce. Acidified aqueous barium nitrate is added to X. White precipitate, 0620_S21_Ms_41. A. Add water to both salts 1. Dissolve both salts, make solutions 1. Filter lead 2 iodide 1. Wash residue of lead 2 iodide with water and dry, e.g. with filter paper. Description of washing and drying 1. 5b. Nitrates decompose when heated. When hydrated zinc nitrate is heated, oxygen gas is given off. Describe a test for oxygen. Test. Glowing splint 1. Observation. Relights rekindles 1. 5b. Complete the equation for the decomposition of hydrated zinc nitrate. 2 ZNOs and 4 NO2 G1. 1 2H2O G1. 5 Ci. Heat again and weigh again. Repeat steps 2 and 3 1. Until mass is constant 1. 2. 5 Ce 0.0051. 0.91. 0.9 divided by 18 smiley face 0.051. 0.05 divided by 0.005 smiley face 10 1. 0620_S21_Ms_43. 5a. Add zinc carbonate to sulfuric acid until it stops dissolving. OR. No more effervescence 1. Filter zinc carbonate 1. Evaporation of filtrate to form dry crystals 1. 5b. Some sulfates decompose when heated. When hydrated iron 2 sulfate is heated strongly, sulfur dioxide gas is given off. Describe a test for sulfur dioxide. Acidified aqueous potassium manganate 7 1. Purple to colorless 1. B. Complete the equation for the decomposition of hydrated iron 2 sulfate. 5c. Some chlorides are hydrated. When hydrated barium chloride crystals, BaCl2 XH2O, are heated, they give off water. A student carries out an experiment to determine the value of X in BaCl2 XH2O. Step 1. Hydrated barium chloride crystals are weighed. Step 2. The hydrated barium chloride crystals are then heated. Step 3. The remaining solid is weighed. Describe how the student can be sure that all the water is given of. Heat plus weigh plus repeat 1. Until mass is constant 1. 5 Ce. M10.02 1. M20.72 1. M3 M2 divided by 18 equals 0.72 18 equals 0.04 1. M4 M3 divided by M1 equals 0.04 divided by 0.02 equals 2 1. 0620_W20_Ms_42. Two soluble salts can be made by adding a metal carbonate to a dilute acid. A. Give the formula of the dilute acid which reacts with a metal carbonate to form a nitrate salt. 2b. Why must the iron 2 carbonate be added in excess in step 2? To make sure all that sulfuric acid reacts. E. State 2 observations in step 2 that would show that iron 2 carbonate was in excess. 2b. Describe what should be done during step 3 to ensure there is a maximum yield of crystals. Rinse the residue with distilled water. 2b. A saturated solution is formed in step 4. Describe what a saturated solution is. A solution that can dissolve no more solute 1. At the specified temperature 1. 2b. Name a different compound that could be used instead of iron 2 carbonate to produce hydrated iron 2 sulfate crystals from dilute sulfuric acid. Iron 2 oxide, iron 2 hydroxide. 2d. State the term used to describe this method of making salts. Precipitation 1. 2d. Give the observation the student would make during step 1. Cream precipitate. E. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous potassium bromide. Include state symbols. 2f. Sodium chloride does not conduct electricity when solid, but does conduct electricity when molten. I. Explain why, in terms of structure and bonding. Ions 1. Ions are fixed in a lattice 1. Ions are mobile 1. 2f. Name the product formed at the positive electrode when electricity is passed through molten sodium chloride. Chlorine. 2f. State the type of change that occurs at the positive electrode in E. Explain your answer in terms of electron transfer. Type of change oxidation 1. Explanation electrons are lost 1. 2f. Describe what else can be done to sodium chloride to allow it to conduct electricity. Dissolve it in water. 0620-S20-Ms_41. 4. This question is about reactions of bases and acids. A. Ammonia is a gas at room temperature. What is the test for ammonia gas? Describe the positive result of this test. Test. Damp litmus 1. Result. Turns blue 1. 4b. Ammonia reacts with water to form ions. I. How does this equation show that ammonia, NH3, behaves as a base? Proton acceptor. 4b. Aqueous ammonia is described as a weak base. Suggest the pH of aqueous ammonia. Above pH 7 up to 11. 4b. Describe what is seen when aqueous ammonia is added to aqueous copper 2 sulfate until no further change is seen. Blue precipitate. Precipitate dissolves. Deep blue solution remains. 4c. Aqueous sodium hydroxide, NaOH, is a strong alkali that reacts with dilute sulfuric acid exothermically. I. What type of reaction is this? Neutralization. 4d. A student wanted to find the concentration of some dilute sulfuric acid by titration. The student found that 25.0 cc of 0.0400 moles per cubic decimeter NaOH reacted exactly with 20.0 cc of H2SO4 I. Name a suitable indicator to use in this titration. Methyl orange. 0620-W19_Ms_41. 4a. Name. I. An insoluble cobalt salt. Cobalt carbonate 1. 4a. An insoluble yellow lead salt. Lead iodide. B. Write the chemical equation for the reaction in which silver carbonate is formed. C. Write the ionic equation for the reaction in which lead 2 iodide is formed. 4d. Aqueous silver nitrate produces a yellow precipitate with both iodide ions and carbonate ions. When testing an unknown solution for iodide ions, the aqueous silver nitrate is acidified. Explain why the aqueous silver nitrate is acidified. Nitric acid reacts with removes carbonate ions. 0620-M21_Ms_42. 8. Write the equation for the reaction in step 1. Include state symbols. 4b. Explain why excess zinc powder is added in step 1. To make sure all the hydrochloric acid reacts 1. 4c. Suggest how unreacted zinc powder is removed in step 2. Filtration 1. 4d. A saturated solution is formed in step 3. Suggest what is meant by the term saturated solution. A solution that can dissolve no more solute 1. At a given temperature 1. 4e. Explain why crystals form as the solution cools in step 4. Solubility of ZnCl2 solids decreases as temperature decreases 1. 4f. Name 2 zinc compounds which react with dilute hydrochloric acid to form zinc chloride. Zinc oxide, zinc carbonate. 2. 4g. If excess calcium metal is used instead of excess zinc powder in step 1, Pure calcium chloride crystals do not form. Explain why. Ca will also react with water 1. 4Hi neutralization. 4He 0.100 times 25 1,000 equals 0.002501. 0.0025 times 2 equals 0.005001. 0.005 times 1,020 equals 0.2501. Mr. equals 41. 0.25 times 40 equals 10. 0, 1. 0620 underscore S19 underscore Ms underscore 41. 4. Ethanoic acid is a weak acid and hydrochloric acid is a strong acid. Both ethanoic acid and hydrochloric acid dissociate in aqueous solution. 4D. A student prepares crystals of magnesium chloride by adding an excess of magnesium carbonate to 50.00 cc of 2.00 moles per cubic decimeter hydrochloric acid. The student filters the mixture and rinses the residue. Why does the student add an excess of magnesium carbonate? To remove the acid, make sure all the acid is used up, no acid is left over. 1. 4D. Why does the student rinse the residue? To make sure all the filtrate MgCl2 salt goes through, no MgCl2 left behind. 1. 4D. Describe how the student would obtain pure crystals of magnesium chloride from the filtrate. Evaporation. Mark 1. The starting of crystallization. Mark 1. Drying the crystals. Mark 1. 4E. Silver chloride, AgCl, is insoluble. It can be made by a precipitation reaction between aqueous barium chloride and a suitable aqueous silver salt. What is meant by the term precipitate? A solid. 1. Which forms when two solutions are mixed, reacted, added. 1.